In this video, we're going to use log properties to aid in differentiating a base A logarithm. So here we have f of x equals the log base 2 of the square root of x, which can also be written as x to the half power, over x minus 1. And we're asked to differentiate f of x, take d dx of f of x, or in other words, find f prime of x. And the first thing we want to recognize is that this log base 2 can be rewritten using log properties. So for example, we can take log base 2. I have a ratio of two expressions, and log properties indicate that if we have a ratio of expressions, we can take the log base 2 of the numerator, and because it's a division or a ratio, we subtract from that the log base 2 of the denominator. That's using log properties from pre-calculus. And now we have a 1/2 here in an exponent position on base x. So we can further use log properties from pre-calculus to rewrite this first expression as 1/2 log base 2 of x, so that exponent 1/2 can then come down in front of our log base 2, and then minus our log base 2 of x minus 1. So here's our function f of x. We've expanded it and simplified how it looks by using log properties, and now we're in a position to take the derivative. So f prime of x is going to equal, we have a constant 1/2, so it's going to be 1/2 times the derivative of log base 2 of x. From a couple videos ago now, we discovered that if we have log base a of x, it's 1 over the natural log of the base times x. So in this case, it's going to be 1 over. It's going to be the natural log of the base 2 times the input x. And then we're going to get minus. Now we have log base 2 of x minus 1. So this is going to be 1 over. And we're going to get the natural log of 2 times the input to the logarithm, which is an x minus 1. So the chain rule would say that we need to multiply by the derivative of x minus 1. But the derivative of x minus 1 is just 1, so that's not going to change anything. And we could probably compact this just a hair and write it as 2 times the natural log of 2 times x minus 1 over the natural log of 2 times x minus 1. And we could find common denominators and combine it, but in this particular case, I don't think that is really going to be necessary. Just kind of glancing at this to see if we have a good reason for simplifying. I think in this case, I'd go ahead and leave it, although I'm really tempted to continue and simplify it a bit more.